Okay, so we need to have a little bit of introduction on how to do problems in science. We haven't really done a lot of math so far. So in science, we know that you can punch things into the calculator and voila, the magic answer. But we really want to understand your thought concept, so you have to show your work just like in every other math class. Science and math are married and they're never going to get a divorce, so you can't take math out of science. So we're going to be talking about the environmental lapse rate. When you're in your car and you go 65 miles per hour, that's a rate. For every hour, how far are you going to go? Or for every how far you're going to go, how long is it going to take you? So in normal conditions, the environmental lapse rate is that the temperature is going to change 6.5 degrees Celsius for every kilometer that your altitude changes. So we're going to use Celsius because that's the scientific SI unit for temperature. Remember, science uses its own little thing so we can communicate about the same stuff. If we have dry conditions, or another name for that is arid, then the environmental lapse rate is going to be 10 degrees Celsius per kilometer. So it makes a difference on the conditions, because when it's cold, the air is very dry, and you notice that. In August here in Georgia, you also notice when it's wet conditions or very humid. That's when you can hardly breathe because the air feels so heavy. And that environmental lapse rate is going to be 5 degrees Celsius per kilometer. And so the equation that you'll use to solve these problems is going to be that the change in altitude, when you see delta, that means change, times the environmental lapse rate is going to give you the change in the temperature. So let's do the sample problem that's in your PowerPoint or Nearpod. Okay, so you're given that if the air starts at sea level, I always draw a little picture because I'm a very visual learner. So here I have the water. Starts at sea level with a temperature of 26 degrees. And what is the temperature at 1,000 meters altitude? So the first step of every problem in science is to write the equation you're going to use. So the first step is write the equation. And from the previous thing, we have the change in altitude times the environmental lapse rate equals the change in temperature. Well, if we started at 26 degrees on the Celsius scale, that's pretty cold. Remember that 0 is freezing and 100 is boiling. So cold means dry. Dry air is cold, warm air is humid. So dry is going to be cold, humid is going to be warm. So let's say that, well, we know from our problem, what we've been given, that it's going to be a dry condition. So we have this next thing, which is to fill in your knowns and set up your equation. So our knowns. We know the change of altitude because we're going from 0 altitude to 1,000 meters. Well, when we're dealing with this equation, we want everything to be in kilometers. So that means we have to change our meters to kilometers. And if you remember these problems where you had the little stair steps, or you have kilometers, hectometers, decameters, and meters, we have 1,000. We're starting here, 1, 2, 3 bubbles, 1, 2, 3 bubbles. So we know that we have 1 kilometer. So we're on step number 2. So we have 1 kilometer times the environmental lapse rate. For dry air, remember that it's 10 degrees Celsius for every kilometer times 10 degrees Celsius over a kilometer equals the change in temperature. So this should be pretty easy. 10 degrees, kilometers disappear because in dimensional analysis it's on the top and bottom of the equation. So it goes away. So we're ending up with 10 degrees Celsius is the change in temperature. Step 3, is to solve. And you have to show all this neat and groovy stuff as you're going along. So this is where a lot of people make a mistake. It's the change in temperature, not your final answer. We started at 26. The temperature changed by 10 degrees. And that gives us 16 degrees Celsius. Now, how do we know that we were going to subtract the temperature? Well, if you think about climbing up a mountain or flying in an airplane, this isn't a very good airplane, but you can pretend, right? Up here with the clouds. Yeah, that's not so good. So you can pretend like you're in an airplane flying around. Or for our purposes, we're going up 1 kilometer. Well, anytime you go up, the temperature is going to go down. So as you go up in altitude, the temperature is going to go down. So the final answer is 16 degrees Celsius, and step 4 is always to circle your answer and check your units. Now let's do another one here in a little bit.